The topic for today is multiplication of radicals. Okay. These rules that we're going to learn will apply to all radicals, like the nth root of a, nth root of b. It could be a square root, a cubic root, any root. So for example, if you have the cubic root of 4 times cubic root of 5, it'll apply to it. So whenever you have a product of two radicals but n is the same, you can multiply these radicals inside a times b, so the nth root of a times the nth root of b is the nth root of a times b. For example, cubic root of 4 times cubic root of 5 is the cubic root of, and then you multiply 4 times 5, which is 20. If these radicals aren't the same, then we can't multiply them this way. We would have to use fractions for these radicals, but that's a subject of a separate video. In this example, we're multiplying root 3 times root 30. So the first thing we do is multiply 3 times 30. 3 times 30 is 90. Square root of 90. Square root of 90 can be simplified. We can write 90 as 9 times 10. Square root of 9 is 3, so this will be 3 root 10. So square root of 3 times square root of 30 can be simplified to 3 root 10. Let's do another example. Square root of 20 times square root of 5. Multiply them. 20 times 5 is 100, and the square root of 100 is 10, because 100 is a perfect square. 10 squared is 100. So the answer is 100. Sometimes, even though we've done this in these examples, and that's a rule, like in this example, sometimes one would be inclined to multiply 54 by 20, but that might not be a good idea. Why? Because 54 times 20 is kind of a large number. Then we would have to simplify it. If we do it that way, it's still correct. However, I always like to simplify before I do anything. So 54 can be simplified. We can write it as 9 times 6. 20 can also be simplified. We can write it as 4 times 5. Square root of 9 is 3. Square root of 6, we'll leave it. Square root of 4 is 2. And square root of 5, we'll leave it. The 3 and the 2 are on the outside. We can multiply them. 3 times 2 is 6. Square root of 6 and square root of 5 are on the inside. We can also multiply them together. 6 times 5 is 30, so this would be 6 root 30. And that's it. And we didn't have to deal with multiplying 54 by 20 and having to simplify it afterwards. If we're multiplying factors that have more than one term, like square root of a plus square root of b times square root of x plus square root of y, treat this like you did with the foiling expressions and products. It's not the foil, but you can think of it that way. So what we need to do is multiply square root of a by both square root of x and square root of y, and multiply square root of b by both square root of x and square root of y. So the first one is square root of a times square root of x. It's square root of ax plus square root of a times square root of y, square root of ay, plus b times x, square root of bx, plus b times y, square root of by. And then when you do this, look at what's inside the square roots and see what can be simplified. So simplify. Let's do another example. Square root of 12 minus square root of 8 times square root of 12 plus square root of 8. Okay. First we multiply root 12 times root 12. Now whenever you multiply root 12 by itself, it's like having root 12 squared, which is just 12. You don't even have to multiply 12 by 12. By the way, if you do, 12 times 12 is 144. Square root of 144 is 12. But you don't have to do it. So square root of 12 times square root of 12 is just 12. Plus square root of 12 times 8 minus square root of 8 times 12. This term times this term. Minus square root of 8 times square root of 8, which is just 8 without the square root. And notice, I'm not going to bother multiplying 12 by 8. It's 96, by the way. But you don't have to. Because 12 times 8 and 8 times 12 have a plus and a minus. They'll cancel. So these two cancel. So that leaves us with only this 12 minus 8. And the answer is 4. Square root of 19 plus square root of 3 times square root of 19 minus square root of 3. Square root of 19 times square root of 19 is just 19. Plus square root of 19 times square root of 3 is square root of 57. And again, we didn't even have to calculate it because the next term, one of them is minus and one of them is plus. Okay, this one is actually minus. And then square root of 3 times square root of 19 is plus square root of 57. Minus square root of 3 times square root of 3 is just 3. The two middle terms will cancel, regardless of which you do first, the plus or the minus. They will cancel. Minus square root of 57 plus root 57, or plus root 57 minus root 57 will cancel. So that gives you 19 minus 3, which is 16. Okay. Earlier, we had square root of 12 minus square root of 8, square root of 12 plus square root of 8. The final answer ended up being 12 minus 8 without the roots. That's 4. In this example, 19 and 3, and the final answer was 19 minus 3, which is 16. This is a general pattern. When you have square root of a plus square root of b times square root of a minus square root of b, you can just forget all of this and then just subtract these two numbers. For example, 208, if I did this one, square root of 101 plus square root of 2, square root of 101 minus square root of 2. Okay, I don't even have to do anything. You have the same numbers here and here, and you have a plus and a minus. It only works when you have a plus and a minus. If both of them are pluses, then you have to go through the steps. So the answer to this would be 101 minus 2, which is 99. Let's do another one of these, 209. Square root of 209, I'll do minus next. Square root of 208. Square root of 209 plus square root of 208. You don't have to do any work. It'll be 209 minus 208, which is 1. 209 minus 208, and the answer is 1. And you can check these on the calculator, by the way. If you do, don't forget to put the parentheses where you're supposed to put them.